great to see everybody. What a good turnout today for the second day of the show. So this talk might be a little different than some of the other talks that you're going to see today. We're going to talk about some new trends in software delivery, but we're going to talk about how a lot of these trends, DevOps and platform engineering, open source and stuff like that actually have their roots in much more ancient thinking. So my name is Justin Reock, head of DevRel for a company called Cortex. We ship an internal developer portal. Happy to talk about that at any point. Previous to this company, I worked for Gradle. I was their field CTO. I know a lot of folks are familiar with Gradle. I focus mostly on their developer productivity engineering stuff. So I've been firmly rooted in sort of developer experience, developer productivity thinking for about 5 years or so, and that's a bit of what we're going to talk about today. So where did DevOps come from? Right? We've actually got John Willis in the audience, who brought DevOps Days to the US back in, I want to say 2009, is that right? I think the understood definition is that in 2009, the term was coined at a show called DevOps Days in Ghent, Belgium. But I think that DevOps actually started a lot earlier than that. I think it started with a mindset, and I think it's this mindset, that it's no longer the big beating the small, but the fast beating the slow, okay? It's no longer the huge, monolithic, big mega corporations and stuff that are just eating everything up, right? It's the smaller, more agile companies that are able to ship features faster and react to market feedback more quickly based on their delivery pipelines and the experience that they build for their developers. And this thinking is rooted in what I like to refer to as the ancient business wisdom of the 1950s through the 1980s, with the thinking of a couple of very important thinkers here. W. Edwards Deming, who introduced a system of profound knowledge, statistical process control, and really reinvented the way that we think about productivity theory in a way that still cascades down into the way that we think about DevOps and platform engineering today, as well as Ellie Goldratt, author of The Goal, and the person who coined a way of thinking called the theory of constraints. Who's familiar with Deming? Oh, John, you got an audience here. Make sure you get a chance to talk to John. He is a Demingite, probably the biggest expert that I know. How about Ellie Goldratt, theory of constraints, The Goal? All right, a few more people. Good, well, we're going to learn a little bit today. How about this book, The Phoenix Project? Who's familiar with this one? Okay, so The Phoenix Project is a direct homage to The Goal, right? So if you've read this book, it's a fictional book. It's a fun, page-turning novel about a VP of software engineering who's struggling to meet the needs of the business and meet SLOs. DevOps, agile thinking is introduced to the business, and everybody wins and everybody's happy, and it's great. The center of the Phoenix Project and The Goal is this notion of the theory of constraints. Now, theory of constraints is very deep. There's a lot to it. It involves thinking about machine physics. It involves thinking about the physics of constraints in general, and how we can use the constraints of a system to our advantage once we identify them. But what we're going to talk about today with respect to DevOps and platform engineering is this aspect of the theory of constraints, which says that we can break any complicated machine, again, this is machine physics thinking, down into three basic subcomponents. Right? The machine has a cost. There's an energy associated with using the machine and making the machine do its job. There's an inventory, right? Just an assembly of parts that work together at some cost to create throughput, which is the job of the machine. So I'm a lawnmower, and I have spinning blades and a chassis and fuel and maybe a human pushing me, or increasingly I'm seeing more of these robot vacuum cleaners around, but there's still, or robot lawnmowers around, but there's still energy associated with making it do its thing. But if that thing is not cutting grass and doing it rapidly and efficiently, well, then it's just a pile of inventory and cost. So what the theory of constraints tells us is that the most important component of this is throughput. It's the identity of the machine. It's the machine doing the job that it's supposed to do. So now the important thing about The Goal was that it applied the theory of constraints and machine thinking to a business, another complex machine. So if you can take a bit of an intellectual leap and think about what the theory of constraints would mean when applied to a software organization, cost is still cost, organizational cost, right? We have to hire our FTEs to put our inventory together. which is effectively code, right? And we want that inventory to ship quickly and efficiently because hopefully that inventory is what's making money for the business, right? We live in an increasingly digitally transformed time. Most businesses are shifting software operations from cost centers to profit centers. And so the faster that we can get that code from the fingertips of developers out to the world making money for the business, hopefully the more profitable our business is going to be, right? So the theory of constraints says that. And this is DevOps mindset, right? How much energy has been spent on making sure that our systems can continuously build, continuously deploy, get our code out to production seconds after we've committed it, right? We have spent a lot trying to reduce that distance. There's another thing at work here too. Any of that code that hasn't been released yet is what's considered work in progress. Work in progress has a cost associated with it as well. There's this thing called entropy, right? Things don't actually sit still, ever. Things rot, and we know code rots too. So the fastest that we can get that code out to production, making money for the business, the closer we are to optimizing for theory of constraints. And so really this is what's important. The only initiatives that'll positively impact long-term performance are the ones that increase throughput while decreasing cost. So layoffs, right? We have a tendency to prioritize cost in the way we think about business, particularly in the West. And so we think that layoffs are going to solve our problem. Well, it's a cost-cutting measure. But if there's not a plan to at least maintain or increase throughput along with that cost-cutting, forget it, right? Your throughput's going to slow down. And we've all experienced some form of this, whether brain drain, the skills leaving the business and things get bottlenecked where they weren't before, right? And we talked about entropy and its relationship. So all of this thinking, this mindset, get that cost out and creating throughput for the business as quickly as possible with as short a distance between hands on keyboard and features out in the world is where this came from, right? Our DevOps conveyor belt. Some of us, looking around a little bit, come from a time where we would write our code and compile it and copy it onto like a drive and like walk to another building and hand that drive to somebody and they would load it up in some machine that was completely different than the one we developed on, and it created all kinds of problems, right? We would, it would take weeks and weeks or months to be able to get that code out. In the meantime, that code's rotting, it's work in progress. So we came up with these things, these DevOps pipelines, these delivery pipelines, the always moving forward conveyor belt, never backwards, right? And that's what this has been in service to. Free software has been a huge part of this. Going back at just a quick look at this landscape here, not all of this software is open source, but a lot of it is. And this is only one permutation of many, many possible permutations of what our platforms and delivery pipelines can look like today. But why is free software so important? Well, we could look at this guy as a cautionary tale. This is Pythagoras. Those who may not know him by face, you might know a squared plus b squared equals c squared, way to calculate the hypotenuse of a right triangle. What a lot of people don't know is that Pythagoras ran a school in ancient Crotone, a school of geometry, where he was teaching to some this new science, this new math that was helping to build cities and infrastructure, and civilizations were built on top of this type of math. And at the time, again, ancient Crotone, we're talking about 700 BC, people in general saw the knowledge as a bit esoteric. Not everybody could use geometry to the level where you could build a sewer or a road or other bits of infrastructure that were supporting the new way that civilizations were working. What a lot of folks don't know also is that there were two subsections of this school of geometry. You had the mathematicoi. Now they were the learners, and they were really the only people in the school who were allowed to learn geometry. You had the acousmatics, who were the listeners, and they were sort of an outer circle of the school. They weren't really being taught geometry, but they were like running errands and things like that for the school. They were part of operations effectively for the school. Pythagoras was sort of arbitrarily selective about who could come in and learn this stuff. But take a quick leap there and think about how that could apply to the way that we build infrastructure today, right? Most of our infrastructure is virtual, it's software. And it is esoteric to a lot of people. But because we have openness about our software, it's very accessible, right? It's not hard to figure out what it is that we're all doing, whereas it was hard to figure out what Pythagoras was doing. And I want to compare that mindset to a guy named Sir Isaac Newton, who published one of the most important pieces of engineering data, which is the Principia Mathematica. This was the first example of esoteric knowledge, engineering knowledge, mathematical knowledge that was put into the public domain, right? Other mathematicians could learn from Isaac Newton's works because of what was published in this manuscript, right? So this is almost like, openness now, open knowledge, right? Open things that can help us move society forward. Things did not work out well for Pythagoras. He died in exile. There was a nobleman in Crotone named Cylon who was not happy about not being able to learn geometry, and was also a noble person, so felt that they deserved, birthright to this knowledge. So murdered a bunch of Pythagoras' students, and Pythagoras was driven out of Crotone and died in exile. Whereas the public domain thinking would lead to things like the Florentine bodega, which were these sort of central public spheres where people from all kinds of cross disciplines would get together, artists and sculptors and philosophers and mathematicians, to discuss the goings-on of the time and talk about how to progressively move society forward. So a little bit like GitHub, if you'll forgive the stretch. All right, so we have DevOps thinking. We have the theory of constraints. We have the will to try to move our code out to production as fast as possible with as few errors as possible, deploying frequently to try to hopefully increase the throughput of our organization. We have free software and open source that makes it very transparent to understand what it is that we're doing, to get our hands on high quality software and use it. And of course, the cloud happened, right? We're in the middle of a new hype cycle with AI, but the last big hype cycle, of course, was the cloud. So how did that convergence of that thinking in open source change the way that we have to write software to take advantage of these substrates? Who's familiar with the 12 factors? Great. Okay, let's pay attention then, because these are important. There's a new version of this that's being worked on right now. The original version was worked on by folks at Heroku, including James Ward, and James is actually working on a new revision of this now. If you want to get involved, it's going to be a fun project. The 12 factors are a way of rating your code's portability, right? How well, if I deploy this code across multiple cloud substrates, is it going to work? And how easy is it going to be to operate? If you miss some of the 12 factors, it doesn't mean that your app is going to fail when you try to push it to cloud or multi-cloud or container substrate, but you should expect sort of a direct relationship between the amount of friction that you experience in your deploy and the amount of lack of coherence to the 12 factors that your app has. They're broken into 12 factors, obviously, and some of these are going to seem a little obvious, but that's because a lot of this has annealed into code practice, over the last decade or so. So the first is thinking about our code base. We want to make sure that we have a single code repository with version control. We don't want to split our application across multiple code repositories because it makes it very hard to automate deployment pipelines out of there. We want a one-to-one relationship between the code base and the app, and we want to be able to carry off multiple deployments from that same code base. Now, GitHub has solved a lot of this for us, right? I mean, if you're using GitHub and you're centralizing your code in that one place, great, you're basically doing this. We want to explicitly declare our dependencies. So, package JSON or build Gradle or pom.xml, whatever you're using, you want to be able to, in your build file, explicitly declare where your external dependencies live so that your build system can grab those dependencies no matter where you're trying to build your code, right? Rather than trying to store them in source control in a way that may make it difficult to perform those builds in different places. Again, a lot of this is just making sure that your builds and your deploys work the same way consistently across multiple environments. Store config and environment variables, right? We're seeing more and more of this. Why? Because it's POSIX compliant, it's easy to understand, it's easy to inject into multiple types of operating systems across all of the major platforms. So it's easy if you have your code running in Kubernetes, for instance, to inject environment variables even if you're just spinning up that environment for a few seconds and it's spinning down again, a disposable environment or whatever, it's easy to manipulate your configuration in those environment variables. Treat your backing services as attached resources, right? So access them through some sort of abstraction, and be able to replace that data source in your application without having to make code changes. Separate your build, release, and run stages. Again, a lot of us are doing this too, but this way, we don't have to have all of these different commands grouped together. We can separate concerns and make sure that if part of the pipeline fails, it's easy to understand where it failed, why it failed, and how to recover from it. Design all your processes as stateless, share nothing processes, again, so that we can deploy them across multiple types of environments, right? Processes are really well understood at this point and easy to manipulate. When you're going to present services from the app, use port binding because TCP is ubiquitous, right? Again, this is another one of those examples, though. I like to have a weird thought experiment about what if TCP/IP was a closed protocol as opposed to something open. We would definitely not be sitting here in this room. If you want to make your app concurrent, scale across multiple processes, right? We've already set up a process lifecycle in our previous recommendation to design the stateless share nothing processes. So do the same thing to be able to scale out multiple concurrent processes again with shared state, but that state being managed in a way that's ubiquitous to all of those processes. Make sure that your apps have a fast startup and a graceful shutdown. Ephemeral environments, make sure that when you deploy in some new substrate, when you want to get rid of that bit of resource or deploy a new branch or whatever, that it cleanly gets rid of the code that was running in there before. Make sure that there's dev prod parity. Nowadays, this just means use Docker. But believe it or not, going back to that earlier example, there was a long, long time where it was actually really difficult to solve this problem, to make sure that the place where we were testing our code and running our code really matched the development environment where we were writing that code to begin with. Treat logs as event streams. Don't make admins go SSH through multiple systems just to figure out what was going on. This is where you've seen the trend around observability, where we no longer write necessarily to a physical log file, but instead push those log events out to systems like Prometheus or Grafana or whatever you might be using. And then run one-off admin tasks for admin processes in the same environment. So don't have ad hoc admin tasks. If you have admin tasks that need to run against the app, write a small app for it and make sure that you can execute it in the same environment. Okay, we got 12-factor, we got open source, we got DevOps. We've simplified our cloud deployments by decomposing all of our monoliths into microservices. And everything's great, right? Yeah, no. All of this freedom and portability has been good for the way that we deliver software. But I think it's absolutely a fair criticism of DevOps to say that there hasn't been enough dev in the DevOps, right? A lot of what's happened as additional responsibility has shifted on to folks in this room, the developer, which means that we have a lot of complexity and disorganization because of these different microservices that are now being managed all over the place. And what does it come back to for developer experience? These three toxic things: toil, unnecessary work with no engineering value, friction, making an unsatisfying experience for our developers, and context switching, forcing our developers to switch their focus from writing code and staying in a good, satisfying state of flow to being forced off onto other tasks, maybe unnecessary tasks, that's toxic and leads to high levels of cognitive fatigue. This is a lot of the state of the art right now that we've done all this decomposition and that we've broken our apps out and put them across multiple clouds. We often have services managed across multiple spreadsheets or wikis rolling up without any real sense of organization. This is a lot of our platform portal. This is a lot of how we keep track of the services that are running and who owns them and where we can go chase people down. So this does not work when folks leave the company or when we have to make changes. There's no this is almost always a lagging system in the way that we are currently and industry-wide organizing a lot of these microservice, mini-service, macroservice landscapes that we have. So yeah, it's pretty terrifying. And not only is that internally disorganized for a lot of our teams, but I also like to think of this as a problem statement. So this picture is the Cloud Native Compute Foundation's software landscape. This is effectively the palette that platform engineers are picking from. Some permutation of this is going to become your software delivery platform. And it's very complex. And you notice that each of these little boxes here, like this is our database box. And there's like a million choices for each category, right? So, I mean, the CNCF has been a great shepherd of technologies like Kubernetes and Argo CD and these important technologies. But they've also been very tools focused, right? They're happy to show you a new tool for some new solution, but not a lot of helping to really align on how we should build these things. And so that's taken us now into this new practice that we're all calling platform engineering. A few years ago, it was platform ops. I don't remember exactly when it went from platform ops to platform engineering, but it's definitely the same thing. And I like to think of this discipline as an intersection of sort of multiple ways of thinking, right? I think that a big part of what platform engineering is bringing that DevOps maybe didn't bring enough of is that focus on developer experience there on the upper left, right? But we're combining developer experience metrics and developer satisfaction and things like this with existing DevOps principles. We're still about optimizing for throughput. We're still about reducing friction and bottlenecks and getting our code reliably out to production as fast as possible. But we're now trying to do this without putting all of that additional complexity on the dev. And I think there's a third aspect of platform engineering too, and I think that's product management, right? We are delivering a platform to our internal customers, developers, right? And we need to treat that software product as if it were a product that we were getting paid for to deliver to our customers, because increasingly that makes our profit centers, our software profit centers, better for the business and more efficient. So I do think platform engineering is kind of an intersection of these three ways of thinking. And a platform might look something like this. Let's see how my spotlight works. It may not work well. We start at the top with some interfaces, hopefully to be able to, I'm not going to do that, it's too much lag. Some interfaces here at the top that we call our portal. You're familiar with Backstage? You've heard of the Backstage portal before? That's like an open source one that's been out for a few years. Spotify pushed it and gives you the ability to build kind of a front end to these portals. That is full transparency what my company does as well. But all of these are fronting other parts of the platform. So we have our integration and delivery plane, monitor and logging. We have our security plane, right? So we've broken out these platforms, into these different sections, and we're trying to piece these things together. And it can get, again, very complex. But this pattern here, which is beginning to emerge, the internal developer portal, is providing, I think, really a fresh and new way of approaching internal developer platforms and being able to make them more organized, more streamlined, and provide a better developer experience. They're effectively, if you think about like Salesforce as a system of record for salespeople and Marketo as a system of record for marketing folks, you could think of an internal developer portal as a system of record for engineering, right? And we haven't really had one. We've had ITSM stuff like ServiceNow, which is good. That helps provide some organization and understand where our assets are. But it doesn't really drive developer behavior. It doesn't really help organizations achieve better excellence. One concept to understand with internal developer portals is that they are not internal developer platforms. IDPs are not IDPs. They are separate. Very confusing. The platform, of course, is that permutation of software that we talked about before that creates the whole delivery pipeline and every part of it, whereas the portal becomes sort of the front end for all that. A big part of why we need to think about building this, and why we have to think about, like, this isn't just a science project that can kind of happen over the weekend, is because of a little thing called Ashby's Law. Anyone familiar with Ashby's Law? Okay, we talk a lot about Conway's Law, Goodhart's Law, but Ashby's Law does not get nearly enough attention. Mid-50s, W. Ross Ashby, cybernetics researcher and also a psychologist, realizes in trying to build robotic systems to control parts of the human body that any system that wants to reliably and efficiently and comprehensively control another system must be as complex or more complex than the system that it's trying to control. We run into this all the time when we try to create comprehensive abstractions and control planes for things that are already very complex. And we wonder, what's happening? How come this just turns into technical debt? How come it's just feature after feature and we're never actually getting what we need? Because of this. You can't outrun it. And this is where we're starting, right? We're starting with something that's very complex. So when we think about building this abstraction layer, if this is something that, is resonating a little bit and saying, I think we could use better organization, it would be better for us to understand where our services were, it would be better for us to have different ways of driving engineering behavior, it's not going to be a weekend project, right? Whatever you come up with, it's going to be as complex or more complex than the permutation of systems that builds your platform here. I like to think about this layer as providing a choreography layer to the platform. So if you think traditionally how we've thought about automation in the past, the automation of one single task is usually called automation. When we have multiple tasks being automated from some central point, that's usually called orchestration. Right? We have a central orchestrator that's manipulating automation across from one central place. So Kubernetes is a great example of an orchestrator, right? With a central control plane that's doing all kinds of fun stuff with our containers. Choreography is decentralized automation, right? So dancers on a dance floor are looking at each other for IQs and trying to figure out each other's tempo. There's no centralization to it, right? So that's choreography. You can think of the internal developer platform as providing choreography in the sense that engineers who are in the portal and who are manipulating parts of the platform are doing so in a decentralized way. At 3 o'clock in the morning, you want infrastructure spun up. You're not bothering anybody. You just click your golden path to production, and you have your infrastructure, and you can start doing your work, right? You don't have to go through anyone else because we've already standardized the way that we're going to create those bits of infrastructure. So this pattern is growing really, really rapidly. We can see Backstage kind of hit the open source market in 2020, and I do recommend checking it out. Again, beware of Ashby's Law. Backstage is a collection of React and TypeScript that you can use as a framework to build a portal, but you are building it. But it's a great way to understand how this abstraction works and how it can help with some of these sort of extant problems that we're seeing in platform. But Gartner is predicting by the end of 2025 that you're going to see 75% adoption of this platform. And speaking just out of experience, we generally see very high ROI when we make these investments and when we make them well. So it's exciting. It is something that is actually new, right? And is helping with some of these other trends like platform engineering. So it becomes a single system of record. So instead of sort of spreadsheets hanging out all over the place, instead we're able to continuously monitor parts of the platform. That unlocks a whole bunch of stuff that was difficult for us to manage in the platform before. It gives us a service catalog. It's a nice single place to go look up where all services are. And hopefully that catalog is continuously monitoring and discovering services through your source control or through Kubernetes, so things don't really become out of date. Providing that developer self-service reduces so much of their toil, friction, and context switching. Imagine not having to open up a ticket and wait 48 hours or whatever, if you're lucky, for some infrastructure tasks to complete. Imagine just being able to get what you need from the platform right when you want it, when you ask for it, right? Production readiness. We're going to get into this in a second. We all have monstrous procedures for this right now. Multi-hour long phone calls, waiting on the one person who's in a 12-hour difference time zone to answer one question before you can know if that service can go out reliably. We're going to talk about that. Security compliance, right? No one wants this, but we need it. We know that there's a good chance right now that the decentralized entity of sort of all bad actors and the money that they make from ransomware and malware and these things may represent the third largest GDP on the planet right now, which should terrify everybody, right? So we need to be able to drive better compliance. We need to understand, how is the health? What is the health of our pipeline? When we talk about stuff like DORA metrics, heard of DORA metrics? It's blowing up, right? One of those DORA metrics doesn't say one thing about the business. Like deployment frequency is a DORA metric. How often are we able, not necessarily do we, but how often are we able to release code to production? Is it once a month? Is it once a week? Is it 10 times a day? If we're 10 times a day, we're doing way better for throughput. Security vulnerability comes out, boom, got that thing fixed in just a few minutes, right? But what does that say about the health of our engineering organization if we can deploy multiple times a day safely and reliably without a lot of failures, as opposed to only being able to do that once a month? It's a distillation of many, many metrics. And then, of course, platform modernization, being able to drive multi-cloud. Let's talk about production readiness. Everybody loves production readiness assessments, right? What's the big problem with production readiness assessments? Well, there's a lot of stuff to check, right? We have a big checklist that our SREs or DevOps folk make that says we got to do this, we got to do this, we got to do that. We got to make sure that we don't have any critical issues open in Jira. We got to make sure that our Sonar Cube is reporting a certain amount of code coverage. And we need to make most of these checks manually, unless we have an IDP that's integrated with these parts of the platform that we would be checking manually. And then we can just do things like continuously monitor the parts of the platform and assign a point weight to some of these different criteria that we need, so that all we ever have to do is just glance at what we call a scorecard. Anybody seen the scorecard pattern emerging? All right, security scorecards was the first time I saw it, but now we're seeing them pop into IDPs because it makes sense. The whole point with a scorecard is that everyone in the organization can see sort of exactly where software metrics and engineering metrics are. And I mean, again, we can be looking at lots of things. We can be looking at security compliance. We can be looking at production readiness. We can be looking at DORA metrics. We can be looking at developer onboarding, right? We can be looking at all these different things, and we can drive them to different levels. We do this by presenting the rules and the current status to everyone in the organization through the portal. This is very psychologically safe. Right? As a developer, if you find out that, our code coverage standard is supposed to be 90% and this service is only 80%, the portal's telling you that. Not a peer, right? Not a boss, right? And also, we've all probably experienced some version of that little bit of negotiation that can happen when maybe we're not meeting a standard, but maybe we feel like we've got something that's very urgent, or maybe we feel like we can talk a security person out of just letting it slide this time, right? There's also not wiggle room here too. We really can stick to our standards. And of course, change them on the fly if we need to. And then DORA and other engineering metrics becomes pretty easy after this, right? We are already integrated with all the parts of the platform that we would be interested in getting this data from, right? So lead time for changes is an important DORA metric. But if we're already integrated with our ticketing system where features are being asked for, and we're already integrated with Kubernetes, right, where our services are going to end up in production, pretty easy to calculate when the feature request came in and when that service was actually out in production, hopefully making money for the business. I think we're going to wrap up a little early. So let's do a quick recap here. DevOps finds its roots in principles of Eli Goldratt and the theory of constraints, which prioritize throughput over cost. In other words, the distance between hands-on keyboard converting inventory into throughput for the business. And that's why we see this big focus on automation and automated delivery, automated builds, and pushing out the pipeline. Without free software, building a modern platform would be incredibly difficult. I might go as far as to say impossible. It would be really, really hard if we had to stop every single time at every single layer of what we're building and deal with licensing or something like that. 12-factor principles can help you take advantage of these modern platforms by adding some ubiquity to your code and making sure that no matter where you deploy it, it's going to work consistently, that it's going to be observable, that it's going to be easy to manage. Platform engineering has arisen to unite DevOps principles that have really emerged over the last decade and a half or so with developer experience thinking and understanding what those metrics are and the importance of them, and product management discipline and delivering a product to our internal customers. The most important part of a good internal developer platform is an internal developer portal. Being able to have that central system of record for all engineers and being able to use that system of record to drive better engineering, better cultures of excellence. And internal developer portals unlock the new developer experience. So, if you want to learn a little bit more, we do have a podcast. I'll flash up a QR code for that in a second. We've had some really interesting folks on the podcast. John's been on. We've had Max Alexander, that some of you may know from LinkedIn. He published the LinkedIn Developer Productivity and Happiness Framework, which the LinkedIn DPH framework. If you haven't checked it out, I highly recommend it. A lot of really good wisdom in there. Most recently, the most recent episode, I had a chance to sit down and interview a neuroscientist, somebody who actually understands things like cognitive load, context switching, flow state, and where those things sort of come from in the brain. It's one of the most interesting conversations that I've had, and that's the most recent episode. So actually applying what we know about neuroscience, cognitive thinking, to developer experience. So if you want to check that out, Spotify and Apple Podcasts. Enjoy the rest of the show. Thank you so much.